So we're going to take a look at this. Here's a question for you. Here's a question. We're going to link this to what we're doing today and what we did yesterday and what we've done the past few days, okay? So just bear with us. If I'm here, if you're here, okay, if you're here and you want to get to here, you walk. You walk. If you want to fly, if you want to go from there to there, how do you go? What's the distance? What's the distance? Yeah. Does it make sense if you are, let's say, if you are, where's Superman? Who's got Superman? Give him up. Give him up. Toss him. If you are Superman, since we started there, you are Superman, and you want to go from one spot to the other spot, okay? How would you go? Would you go that way? You'd be able to fly, right? You'd be able to fly. Woo, Superman. Woo. Okay? You'd be able to fly. Now, if you are Iron Man and you're flying, okay, and you're flying, can you fly? You would go that way. You would go that same direction, right? You would fly. Fantastic. Excellent. Now, how would Batman do it? Would Batman drive his Batbike? Would Batman drive his Batmobile? Or would Batman fly? He has a Batjet. Y'all know he's got a Batjet thing. Batman flying. How would this guy go? Would he fly? Thor flies. Okay, Thor flies. How would Hulk get there? Would he jump like a beast? If he's raging, he might just run straight through all the walls. So he's still going on the blue route. Dang it. It's going through the blue route. Now, Captain America. How would Captain America get there? The upstanding student or citizen, Captain America, the respectful Captain America, would he run through buildings? Would he throw his shield through buildings randomly? No. What would he do? He would probably take a nice leisurely walk in his really tight suit. Okay? Or, if he's in his normal clothes, he just might take a taxi cab. Okay, so that whole discussion about the superheroes, poor Captain America would probably run, because why would you walk when you can run that fast? He would probably walk down the streets. He wouldn't even go through the buildings or the homes or whatever. Could he go this way? Assuming it's not a one-way, could he go this way? This way. Is that... So that would be his distance, right? That's a totally different distance than as the Superman, Batman, Iron Man, Thor, and Hulk all go. That's a totally different distance, isn't it? All those other guys would go straight through, could go straight through. Whereas Captain America would have to go around and go down the streets because he's an upstanding citizen. He's not going to disturb anyone. He doesn't have to. He's Captain America. He's a nice dude. So yeah, he would have to go that. Are those the same distances? No. There's real distance. There's the distance that's blue. That's like actual distance, like as the crow flies. Okay? Then there's distance like in the black state line that we would consider that potentially taxi cab distance, or as the taxi cab would drive, right? You're going to look at a packet right now. We're going to take a look at what's called taxi cab geometry. Taxi cab geometry is literally that. How would a taxi cab get from one spot to another? Taxi cabs in city blocks like this will only take right turns, right? They won't go diagonal. They can't go through the buildings. So like you pretend like on the coordinate grid, all those spots in between, there's full of buildings, and a taxi cab can't drive through those buildings. Okay? So when we're trying to interpret this in terms of taxi cab distance, the easiest way is to actually count, like 1, 2, 3, 4, 5, blah, blah, blah. And you would, in this case, you would probably term it blocks, like people do in the city. I know we're all well versed with being in the city. We're all city folk here. You would count the blocks and maybe call them blocks and avenues. In terms of ours, we're going to call taxi cab distance, which is different than regular distance. All right. All right. Take a look at the first question on that packet right now. Calculate the distance. What is the first taxi cab distance, E to D? The taxi cab distance would be just essentially to count the horizontal vertical. 1, 2, 3, 4, and then 1, 2, 3, 4, 8. Total of 8 units. 8 taxi cab units. How about D to C? 4 and C to E. Well, let's talk about D to C for a second. Is that 4? That's 4. How about this? Is this 4? Whoa. Is this 4? Is that 4? They're all 4. Yeah. It doesn't matter which way you go there as long as it's a pretty direct route. Okay. All right. C to E. What is that distance? Did you count it? C to E? 8. How about E to C? 8. The reverse is also 8. There's no one-way streets in taxi cab. All right, numero 2. Locate all the points exactly. See 3 taxi cab units away from the given point. How are you going to do this? You count. 1, 2, 3. 1, 2, 3. Are there more spots where it's 3 away? Where? These guys, right? Those are both 3 away? Yeah, absolutely. These are both 3 away. These are both 3 away. Are all of those 3 away from the center? Would it be closer? Are there anything 3 away that's closer? Mm-mm. Guys, you ready for this? This is gonna be exciting. I'm gonna tell you the definition of this circle. Ready? A definition of a circle is a set of all points that are equidistant from a fixed point called the center. Is that a circle? Is that a circle? Does that fulfill the definition, the set of all points that are equidistant from a fixed point? Is that all the taxicab spots that are that distance away? Is it? It is. That's in fact, that is 100% a circle. Okay. Circles in taxicab world, folks, look like diamonds or squares. Do the next one and be inspired by the beautiful music. Very good. Yeah, it's another diamond looking shape. It kind of looks like, it's really kind of like a square. You can't really call it a square because it's not connected. It's not a quadrilateral. 4 taxicab units, 4 taxicab units, 4 taxicab units, 4 taxicab units, and all the dots in between. It's not a square. Do you know why? Do you get why it's not a square? It's not a square because those dots aren't connected and they're not sides. They're just dots. Okay? You got it? Good. Let's go to the next one. By the way, while we're looking at the next one, does anybody find this a little refreshing from some of the difficult stuff we've been talking about right now and from proofs? Like, I feel like this is nice and refreshing. Will this be on the quiz? Yeah. Will it be on the test? Yeah. Stuff like this. One of these guys is distance. One is taxicab distance. The taxicab distance is B. That's the 13 that you can count, right? The other distance references from B to C references that. Yeah, how do you find that? You can. Why are you concerned with not being, why do you think you can't? Why? There's no, what's one strategy to get those? To get that distance? What's one strategy? You use the formula. What do you need to use the formula, though? What do you need to be able to have in order to use the formula? Do you have an x1 and an x2? Do you have a y1 and a y2? No. We need to make them, right? Are there coordinates on here? Are there axes on here, rather? No, there are no axes on here. So you could almost put your axes anywhere if you wanted to do that, okay? And you just label points based off of those axes and use it, and you'll get the correct distance no matter where you make the axes. A second way to do it, which also connects with stuff we've done before, so you see what's in the picture right now? What's the right triangle? If we know two sides of the right triangle, can we find the third? We know this is 6 and that's 7 when you count it. Okay? You could do then 6 squared plus 7 squared equals d squared. And I know that's evil because I didn't make it c. And seriously, y'all want it to be c. It doesn't have to be c. It just has to be the hypotenuse. So you get 36 plus 49 equals d squared. Get 85. So you get squared 85. So what's the answer? What's the answer? What's the final answer? Square root 85 is the final response, right? If you typed it in your calculator and wanted to get 9.2, don't give me that. I asked for the distance. I didn't ask for almost the distance. I asked for what the distance actually is. If you wrote 9.2, you gave me almost the distance. You didn't give me the distance. You know what I'm saying? Okay. Almost the distance is a rounded number. When you get 9.2, you rounded it. You almost got there, but you're not giving me the exact. Yeah. All right. Next question says, what is the taxicab distance if you travel all through those points? Which is kind of exciting. How are you going to do that? What's the strategy? Start at B and then go to C. Just count, right? Count, and then go to D and you count. And then you go to E and then you count. And then you go to F and then you count. And then you go to G and then you count. And if you want to go a different way, you can go a different way if you feel like it. Okay? If you want to go a different way, you can do that. Like you can take this, you can go down here. Okay? If you do that, that's going to be the same distance. What is that distance? 42, I believe you. There is a shortest route, and the shortest route is 42, but there are multiple shortest routes. Choose your own adventure. I know, mind blown again. There are multiple shortest routes. So let's go to D. On D, there's actually only one set of combination that actually works. One set of the perfect ordering of the points visited. Would it make sense to go to F first? Why? It's out of the way. You're going to wind up double counting these 3 units. That makes sense? Because you're like going through the middle. Go around the outside. So you go B to E to F, probably to D to C to G. Right? B, E, F, D, C, G. Why would you even visit all bunch of different points? Why would it be important for you to organize like where you put those points? Well, if you're like a package delivery guy in the city on a bike, you ride your or guy or gal, and you ride your bike all over the city. You could do that. You could order them. You know which way you get there. Okay. Raise your hand if while growing up. We got some folks counting it as 32. Yeah, the actual distance between those is 32. Super. Oh, somebody got 30. Uh-oh. You know what? You probably doubled up in one spot if you said 32. Find the spot that you doubled up between them with your drawing. Okay, there'll be like an overlap that's in there that doesn't need to be there. 3. I'll believe you guys is 30. I'm not going to count it because I know I'm great at counting. You guys have evidence of that when I pass out papers every day. Good at counting. Good at counting. All right, numero 50. Short distance. Why don't you guys do it? So what is the appropriate path from L to K? L what? That works. How many is that? 29 paths? 28? There's dissension in the class. I'll count it. This one I'll count. I kind of feel like it's 28. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 is right. 29. Boom. Find the overlap. Find the mistake. Make sure you know it. Your homework's the next 2 problems. You're welcome.